Hi. Creating a system for MCP orchestration, web apps, and B2B integrations should be as simple as identify an existing database and describe the logic in natural language. And with the right infrastructure, it is. Here's how. We issue this command. The system reads the existing schema and creates a complete project and then opens it in VS Code, ready to run. A CRUD system is useful, but enterprise systems require logic. We declare that logic in natural language, and Copilot translates it into governed rules. At this point, the system exists, a complete running project with a governed API, MCP orchestration, and an admin app. Nothing else is required. 2 prompts produce the system you're seeing. The system expresses business logic as declarative rules executed by the engine. We can set a normal breakpoint. Using MCP Discovery, let's use Copilot to test the update. The engine chains the logic, item to order to customer, and blocks the change because that would exceed the credit limit, exactly as declared. Notice how Copilot even explains the rule firing. That's governed business logic. Notice the rules file. This is a rules DSL executed directly by the engine. Natural language is translated into a formal rules language, so business intent is unambiguous. The engine determines ordering and manages dependencies automatically, allowing a few lines to express what Python would require hundreds of lines to accomplish, while preserving a high level of abstraction for understanding and debugging. Rules become a durable corporate asset, readable as documentation, enforced as execution, and shared by IT and business users alike. When needed, the system can be extended in Python, but those extensions are still declared and executed through the same logic engine, appearing explicitly in the rules DSL as events for integration and agentic logic. Because ordering is automatic, rules can be maintained without code archaeology, enabling the safe, rapid change enterprises require. Rules are declared on the data and enforced inside the API, so reuse is automatic in 2 important ways. First, reuse across use cases. For example, pricing is applied whether an item is inserted, deleted, or a product is reselected, eliminating the corner case bugs that are the hardest to find and the most expensive to fix. Second, reuse across transaction sources. Unlike logic embedded in UI workflows, the same rules apply to APIs, headless integrations, and B2B transactions automatically. This is the execution contract, and it does not change. Governance the enterprise can depend on. This rule is agentic. It asks AI at runtime to choose the right supplier, for example, if the Suez Canal is blocked. We can use the automatically created admin app to order some Egyptian sheets. Because the choice is probabilistic, the system records every request, response, and rationale, providing auditability for review and governance. AI agents are useful at proposing actions, but in enterprise systems, proposals aren't enough. Execution must be governed because someone is accountable for the outcome. That governance comes from rules executing at commit time, the point where every proposed change, from APIs to AI agents, is either accepted or rejected. At this point, we're no longer talking about code or workflows. It's about an agent shaped by governing logic. If you step back, what we've built here is really something familiar. This isn't a collection of generated files. It's a running enterprise-class server that operates as part of your infrastructure. Just as a database is given a schema and executes and optimizes queries, this system is given business logic and executes and optimizes transactions with governance built in. The business expresses policy in natural language. The business logic agent, as infrastructure, executes it, ensuring governance on every change. Try it yourself. It's free and open source. And get in touch. We love the feedback. And thanks for watching.